In this video, we'll take a look at Chaos Flesh to simulate real-time soft-body physics in Unreal 5.2. I'll go over how to set up and simulate Chaos Flesh, and also how to bind or transfer those simulations to a rake or skeleton as well. We'll start off by creating a simple simulation like this. So we'll start off by creating a simple setup of Chaos Flesh to simulate a ball or a balloon being dropped and deforming once it hits the ground. To do this, we'll first go to Edit, Plugins, and make sure that we have our Chaos Flesh plugin enabled and loaded. Once we've confirmed that, we're going to have to create a couple things. We're first going to have to create our Flesh asset, and then a data flow graph to determine how that Flesh asset functions or what exactly happens inside of it. And that's where we're going to assign our soft body properties to our object that will determine how it deforms. And then we'll also have to create a solver to carry out the simulation. So the first thing we'll want to do is right click in our content browser and go to physics and create a Flesh asset. And I'll call this FA for Flesh asset and then balloon. And if we open up that Flesh asset, we'll see that there's options here to drop in a static mesh or skeletal mesh, but none of that's important right now. What is important is our data flow asset. This is going to determine what this Flesh asset actually consists of. So we're going to have to go back down here into the content browser and right click and go to physics and create a data flow graph. And I'll call that DFG for data flow graph and then balloon. And I'll drag that data flow graph into the data flow asset slot of our Flesh asset, and I'll save our Flesh asset and close it. And now when I reopen up this Flesh asset, it will open up our data flow graph. So this is where we'll determine pretty much everything that this Flesh asset does. And if you don't see an interface that looks like this, just go up here to Window and make sure you have all these things checked on: skeletal hierarchy, data flow viewport, just so you see a similar interface. Now the first thing that we're going to do is start off with our static mesh. So I'll create a static mesh node, and for the static mesh node, we'll drop in our static mesh. So I'll drop in this ball that I have here. And then what we'll have to do is turn that static mesh into something that could be simulated with Chaos Flesh or soft body properties. And that would be a kind of tetrahedron mesh. So I'll drag this out, and the new node that I'm going to create here will pretty much take our mesh and convert its geometry into kind of like tetrahedrons, or kind of like more geometric shapes that are better for simulating soft bodies. So I'll drag this out and do something like a generate tetrahedral collection. And I'll connect this all up. And if we want to see what that does, we can flip this little switch here and it will output it to the viewport. And there it is. There's our ball now converted to these tetrahedrals. And we can change some settings. Generally, the number of cells you need is not so much as I have here. For something this simple, I could probably do 6 or even lower, but let's try 6. And then that will be less geometry, less density. There's also different ways you could do tet wild or ISO stuffing. So different ways of taking this mesh and converting it into these tetrahedrals that will be simulated. But I'm going to do ISO stuffing, number of cells. I think 6 should be okay, and that should all be good. So once I've done that, I can just flip the switch again to force it to update. Now you can see it's a bit more simplified. Now the next thing that we have to do is make sure that we apply properties for this. So I'm going to drag this out here and go to add a new node called set flesh default properties. And I'll connect that up. And this is where we set our properties for density, stiffness, and how this object is going to react to the simulation. So for something like this, you'll have to change these dependent on what you're trying to simulate. But for something like this, I'm going to make really low density, so 0.01. Vertex stiffness, maybe 8,000. Vertex dampening, maybe 0.1. And vertex incompressibility, so the vertexes don't just collapse on themselves, maybe 0.75. And these settings will have to be changed also if you start to change this number of cells for the tetrahedral collection. Sometimes that will affect how it reacts, so you'll have to kind of kind of test it out and see what works best. Now, I'm pretty much done setting this up, so I have to create one final node to end everything, and that's the Flesh Asset Terminal node. So we'll go here and search Flesh Asset Terminal, and that's our very ending node that kind of outputs the result. I can flip the switch on it just to preview the output to make sure something's showing up. And that's pretty much it. Now I can save the Flesh asset. I can drop it into the scene here already, and I can place it up in the air. But this won't simulate because we don't have anything to solve or process the simulation. So I'm going to have to go up here to this plus and click on it and search deformer. Or deformable solver actor, and create that. And that will do our solving of this simulation. And I have to connect that solver to my Flesh asset. So I'm going to go to this Flesh asset balloon that I have here, or Flesh actor, and go to Physics tab, and you'll see this primary solver. I'm going to click down and connect that deformable solver. So we'll use that deformable solver to do the simulation. Now, one last important thing before we run this simulation. I don't know if this behavior happens for other people's Unreals, but if I have the Flesh asset selected or the deformable solver actor selected, and I go up here and click play or simulate, it kind of freezes up my Unreal for a good minute or so for no real reason. So I find it's better to select something else. Let me just select maybe this folder here or something, or some other object, and then if I go up here and simulate, well, then it runs instantly. And you can see that now we get this kind of water balloon jiggle and drop on that ball. So there we go, our real-time soft body physics simulation with Chaos Flesh. Easy to set up and runs quite quick. So what if I'm wanting that simulation that we just had, that soft body simulation on that ball, but for it to be transferred to our proper mesh that has better looking geometry, that doesn't look kind of weird and faceted from that tetrahedral look. So what if I want to do that? Well, we're going to have to create a bit of a skeleton in our mesh that we want to deform. So I did something really simple. I took that ball, added some simple skeleton in here to control all 6 sides of it. So back, bottom, front, left, right, top. And these joints can just control the deformation of this ball. So I have that all set up now, and the idea is going to be that we're going to track all these different points of our tetrahedral sim mesh. So we're going to take our tetrahedral sim mesh and take the skeleton and have the skeleton track these points on that mesh. And when those points deform from that sim being simulated, it will also affect these bones. So it will take these bones and it will push them in or out to deform this ball similar to how our sim is. So that's going to be the idea behind what we're going to do. So I have to create this little bit of skeleton in the mesh. Once I have that, I'm going to drop this mesh into our scene with that skeleton. And I'm going to go here and take this mesh, or this skeletal mesh, so the skeleton with the mesh applied, and I'm going to go here to where it has this little icon that will turn it into a blueprint. And I'll leave it as a new subclass, skeletal mesh actor, sure, select, and now we have our blueprint. So now we have a blueprint of our skeletal mesh of this ball with its rig. And I'm going to add a component. The component I'm going to add is going to be a flesh component. So I'll add a flesh component. Now in this flesh component, we'll be able to connect up kind of our flesh asset. But we'll talk about that a little bit later. Before doing that, we're going to have to set up something in the construction script. We're going to have to make sure that this blueprint can be attached to a solver, and that solver can be used on this flesh component. So I'm going to take this flesh component, drag it into the construction script, get flesh. I'm going to create a new variable called solver and make that type a deformable solver, actor, object reference. Turn the little eye icon on so we can connect it up to a solver from outside of this blueprint. When we place it in our scene, we can just connect it up. So I'm going to make sure that little eyeball is on, and then I'm going to drag this solver into our construction script here. So there it is, our flesh and our solver. And all we want to do now is create one more node. Let's drag it out from here. Enable simulation from actor, flesh. And oh, it already creates our flesh node, so that's great. We can just remove that. And deformable solver actor will be our solver. There we go. That will attach our solver to our flesh actor or flesh component in here. Next thing we have to do is in the event graph. Under event tick, every single frame or every single tick, we're going to have to check to see if there's updates on that deforming mesh. And if there is, we have to update our skeleton or update our mesh with that skeleton that will take those changes. So to do this, we have to do something that's a little bit abstracted here. I don't know the details behind it because there's not too much written up about it. But we can take our event tick, and what we're going to do is cast it to Optimus Deformer instance. And this is kind of what Unreal has that will allow us to deform our mesh and kind of do all the heavy lifting of what's going to have to be done to make this work. So we're going to take every event tick, we're going to cast to Optimus Deformer instance. The object we're going to cast to with will be our skeletal mesh component. But we don't want to just connect up our skeletal mesh component. We want to take our skeletal mesh component and we want to get our mesh deformer instance. So we can do get mesh deformer instance and then connect that up like that. Now after doing that, we have to pass some flags or variables over to this Optimus Deformer. And those two flags and variables are going to be the sim to render variable and the amount variable. And the amount variable will be like a blend. The sim to render variable just kind of has to be toggled. So what we'll do in here is we'll create a variable called sim to render. We'll set its type to transform. That's like the transforms. Turn the eyeball on, drag it in here, get sim to render. And we're going to drag out this here and do a set variable with the same type, set variable transform. Connect up our sim to render variable. Variable name will be sim to render, capital S, capital T, capital R, everything else lowercase. Target will be our as Optimus Deformer instance. Same thing, set variable, but this time a float. And we're going to create a variable called amount, which will be a float. And this is kind of like a blend amount. How much percent does it use of the sim versus maybe our animation or whatever else we have going on if the joints and things are moving. So it's almost like a blend factor. By default, we want it 1, which means fully using whatever the deformer is doing, so or whatever the sim is doing. So we're going to click compile. I know it will give me an error, but I just want to set this amount to 1. And then we'll connect that up to the in value here. Variable name, amount, target, as Optimus Deformer instance. Done. Now compile, no errors. We're all good. So that's what we have to do under our event graph. And this will pretty much update our transforms and our mesh every frame, every tick. So we'll save that. Now, most things are done. We just have to create our Flash asset now. After we create our Flash asset, we're going to have to connect it up to our Flash component here as our rest shape, which we'll go over, our rest collection, not rest shape, under physics here. But we have to create that Flash asset first. And our Flash asset's going to have a slightly different graph than it did the time before, because we're going to have to do some extra things like having our skeleton bound in there and having that surface properly deform. So the next thing I'm going to do is create our Flash asset. So I'll right click, go to physics, Flash asset, FA balloon, I'll just call it again. Again, data flow graph, right click physics, data flow graph, DFG for data flow graph, balloon, open up the flesh asset. I'll connect up my stuff here, so skeleton, static mesh, skeletal mesh, skeletal mesh. It doesn't really matter actually at this point, but we'll connect it up. Pop in our data flow graph, save this, close it, reopen up our flesh asset. Now it's our data flow graph, and we see our little hierarchy here of our bones because we connected up our skeletal mesh and all that, but it doesn't matter too much because we could just reference it again. And this is going to be very similar to before. We first have to generate our tetrahedral collection mesh. So I'll do static mesh of the ball. So static mesh, load in that static mesh, whoops, of that ball. There we go. And then do our generate tetrahedral collection. Okay. Number of cells, I'll do 6. Then what we have to do is a couple different things. First thing is we're going to have a node called kinematic tetrahedral bindings. What this will allow us to do is take our tetrahedral collection or tetrahedral mesh, take our skeletal mesh, so I'll create a new skeletal mesh here, connect up my skeletal mesh, and what it's going to do is allow our skeleton to control that tetrahedral mesh. So if you wanted to have like a character where its arms are moving, but his arms are really kind of like almost like wings or has a lot of muscle on it, and you want to see that muscle jiggle, you could essentially have these bones control the movement of your tetrahedral sim mesh, but still have those tetrahedral sim mesh work with its properties and do its jiggle and whatnot. So this allows us to have a skeletal mesh that can actually control and hold and kind of move and make our sim mesh follow those bones as well. Now in this case, we don't want to have our skeletal mesh be like a firm skeleton inside that ball. It's simply just for deforming our ball. We don't want that skeletal mesh to be holding up the ball like a structure. So technically we don't need this node, but this is important for if you want to have some bones driving the movement of your simmed mesh. So in this case, since we don't want those bones to be driving any of the sim or anything, we can just disable this, set active to off. You also have the option of active was on to exclude certain bones. So you could say, okay, all these bones will affect it except the top joint or the joint right or joint left it will ignore. So you can do that as well. You probably want to play around with this to really get an idea for what it does. But in this case, we don't want our skeleton to be binding or modifying or holding up the structure of our tetrahedral collection, our sim mesh. So I'm just going to disable this for now, active off. So that's kind of an optional thing if you need it. Now after this, we're going to do a generate surface bindings. This will allow us to properly, you can see here, generate barycentric bindings. So it's going to be used by a flesh deformer or deformer graph to render a surface to a tetrahedral mesh. So we're going to need this, and we're going to connect up the collection, connect up our skeletal mesh. Other stuff won't matter too much. We could pop in our skeletal and static mesh in here, but we're already connecting them up, so don't think we really need to do that. And then after this, we can do our set flesh default properties, just like we did before. Density 0.01, stiffness 8000, dampening 0.1, vertex incompressibility 0.75. Let's go with that. And then finally, flesh asset terminal node to end this. And that's it. Save it, close it, go into our blueprint that we have here in our scene, or blueprint skeletal mesh. I'll drag this ball up into the air. I'm going to edit it. we have to connect up that flesh asset now. So what I'm going to do is go in here to flesh component. You'll see this under physics rest collection. We'll connect up our flesh asset balloon. So it's connected to that flesh component. We'll save this. And since we have it in our scene here, a couple things we have to do. We have to add our solver. So we go up here and add our deformable solver actor. We go to our ball here and we search solver because we have that variable called solver. There it is. We'll connect up our deformable solver actor. That's done. And now one thing you can do to test, we're going to actually hide our hero mesh here. So I'm going to go to SM, balloon, skeleton, blueprint, self. I'm going to go to visible, turn it off. So you just see our flesh component. And I'm going to simulate and see what happens. So it falls and does what we expect, like what we had before. Cool. So that means it technically should work. The sim is working. So I'll go back here to my static mesh. This time I'll turn the flesh visible to off and put the skeletal mesh visible to on. And let's test this out. And it's not going to work. We're going to see it fall. Well, actually, we won't see it fall because we need to enable physics. So I'm going to go in here and on this, I'll do simulate physics on. Then I'll simulate it. Okay, it falls, but it's not deforming. So there's one very last thing we have to do to make this all work. And it's only for if you're deforming a mesh. And if I click on this skeletal mesh here that we have as a blueprint and I search for deform, you'll find this mesh deformer option that's checked off. We want to check that on and we want to add a mesh deformer. And the mesh deformer is going to be a DG underscore flesh deformer. That DG underscore flesh deformer is something that Unreal has by default with the Chaos Flesh, which will do all the kind of heavy lifting of making that mesh deform. So they have an extensive graph here that does all that. So that's something that is pre-set up. We just have to make sure on this that we turn the mesh deformer on and select the DG flesh deformer. And if we do that now and we simulate, there we go. We have our more high quality renderable mesh doing what our Chaos Flesh sim is doing and transferring those deformations that are being simulated over to our other mesh by pretty much controlling our rig or our bones, which can deform this ball. So there we go. Now we have a full setup of real-time soft body physics in Unreal using Chaos Flesh. If you enjoyed this video, if you learned something new, don't forget to like, subscribe, press the bell button for future notifications of videos, and check out the Patreon in the description below. If you're part of the Patreon, you'll get access to this PDF that goes over all the steps we went over in this video, and even a little bit more information. This PDF will also cover how you can add collisions with your soft body meshes. So how can you have other objects in your scene that can collide with your soft body physics or Chaos Flesh as well. So if you're part of the Patreon, you'll get access to that. And don't forget to type in the comments down below what you learned from this video, what content you'd like to see, or what other tutorials you want to see next.